In this video I'm going to talk about the sum of the first n Fibonacci numbers. So basically the Fibonacci numbers are defined recurrently. This is the definition. So the first two terms are equal to 1, and then each term is equal to the sum of the previous two terms. The main statement that we are going to prove in this video is that the sum of the first n Fibonacci numbers is equal to fn plus 2 minus 1. So the proof is going to be by induction. So first we check, so by induction. So first we check the case of n equal to 1. So on the left side we have only f1. On the right hand side we have f3 minus 1. Okay, so f1 is equal to 1, f3 is equal to f1 plus f2, f1 plus f2, which is equal to 1 plus 1, which is equal to 2, and minus 1. So this would be equal to 2 minus 1 equal to 1. So the equality holds. Right, so now we assume that it holds for n. So assume that it is true for n. Consider for n plus 1. Consider for n plus 1. So for n plus 1 we have f1 plus f2 plus and so on plus fn plus fn plus 1. We need to find this sum. But we need to prove that it is equal to fn plus 3 minus 1. We are going to find what the sum is equal to. So the first n terms in this sum are equal by inductive hypothesis, are equal to fn plus 2 minus 1. So this is by inductive hypothesis. So this whole sum is equal to fn plus 2 minus 1 plus fn plus 1. So the last term we just rewrite it as is. So now this is equal to so now we observe that we have the sum of two consecutive Fibonacci numbers here, and by the original recurrent relation by this we can rewrite it as the next Fibonacci number. So fn plus 2 plus fn plus 1 is equal to fn plus 3 minus 1. So minus 1 remains as this, and this is the sum of these two numbers. Right? So, and this is actually exactly what we needed to prove. Yeah, so on the right side, this is exactly the result that we need for n plus 1 in the original formula here. So basically this concludes the proof.